Hello, everyone. Thank you for attending today's webinar, What Network Teams Need to Know to Be Successful in 2023, presented by Kentik Technologies. I'm Andrea Anderson, and I'll be moderating this webinar. Let's get started today. I'd like to begin by introducing today's speakers. We have Mattias B. Fridström, Vice President and Chief Evangelist, Arelion, and Doug Madory, Director of Internet Analysis at Kentik. You can read their full bios on the left side of your window by selecting the Speakers tab. Our agenda for today, first, we have the introductions. We will learn about Arelion. We will discuss DDoS trends and insights. We will cover Russia and Ukraine. We will go over the state of RPKI adoption. We will review global AS rankings, and then finally we will have a Q&A. I have a few other notes before we begin. To access additional resources for today's presentation, please click the Handouts tab button on the left side of your screen. This webinar is being recorded and will be available on demand to watch within 24 hours. We'd love to hear from you during the presentation. Please submit any questions you have using the Questions and Answers tab on the left side of your screen. And time permitting, we will conclude with that Q&A session. All right, it's time to hear from our speakers. Mattias, please go ahead.
Thank you very much, Andrea. For those of you that have never seen me or heard anything, I'm the Chief Evangelist of Arelion. I used to be the CTO for many years, but I'm now the Chief Evangelist trying to figure out what we need to do better and what the world needs to do better. So I work for a company called Arelion. We used to be known as Telia Carrier, but Telia sold us a couple of years ago, and therefore we had to rebrand, and the name is now Arelion. But practically everything that was Telia Carrier before is now Arelion. So whatever I speak around here is the company Telia Carrier that is now named Arelion. We are a global provider of capacity services and IP services, and obviously a heavy user of the KMI tool that we will talk about later on in this webcast, the Kentik tool that is actually ranking all the networks around the world, and that's why we refer to ourselves, as you can see on this slide here. A company that is predominantly in Europe and North America, but we do serve more than 125 countries around the world. So that's pretty much Arelion. This slide is just showing that our internet backbone that we're going to talk about here, around DDoS attacks and everything else, is practically in the middle of everything. We do serve, on one side, global content providers and others who want to share things on the internet, and at the same time, there are a lot of ISPs, mobile providers, and everyone else who have users of the internet services and the content services. So we're in the middle of all this, and thereby we do see a lot of stuff in our network, and that's pretty much what we're going to talk about here, with specific focus on DDoS attacks and what you can do to prevent DDoS attacks around RPKI, where Doug will talk much more about RPKI and the development in that area going forward. So let's jump into the topic with DDoS attacks. And basically, as you can understand, as a large internet backbone, there's a lot of things we can see in our network. What I will talk about today is everything that we can see in our network. So this is nothing general about the internet itself. You know, public internet is more than 100,000 networks connected together. We are one of those 100,000 networks. But obviously, we're one of the largest ones. So there's a lot of things we see. There's a lot of things that is unique to us. But everything I will present here is the unique data that comes from our network. So this is sort of no overall picture of the DDoS attacks in the world. It's what we can see in our network. So when we jump into this, these are data that is until the end of last year. I've also actually looked at the first part of this year, Q1, and the trends are the same as we could see the last year. But I think the overall trend we can see now is that in our network, the number of DDoS attacks are actually shrinking. You can see that the trend until sort of 2021 was that attacks were increasing every year. But what we see now is actually a decrease in the amount of attacks on the network. There could be various reasons behind that. We're still doing some analysis around that. I think the general awareness in the world about these things are higher, and therefore people are starting to protect their networks much better. But I also think there is a DDoS traceback group formed, I would say, last summer, where the largest internet backbones and some large content providers are actually on a weekly basis sharing information about these type of attacks, and thereby learning from each other and protecting the networks much better. So the trend is a combination of everyone being better to protect themselves and the largest networks working much better together to sort of stay away from having these attacks in the network. When we jump into the network itself and the amount of attacks and the type of attacks, these attacks typically come in two different fashions. The volume attacks, where you just put a large chunk of traffic towards a destination to kind of beat that destination to get it to stop working. And the other one is, of course, the protocol attacks, where you, in some smart ways, are trying to figure out ways of getting servers stop working by manipulating the traffic to them and for them. And here you can see that we do have both of them in our network, and the trends is, again, slightly declining here, which is, of course, a good sign if you are someone who wants to protect these type of networks. If you go into the statistics around the size of them, I would say the trend is that attacks become smaller and smaller, faster and faster. Therefore, you can see that very few attacks are long. Attacks are typically very short, and therefore the mitigation is needed to be super quick. If you wait too long, the attack is over and the target is hurt, and you have problems fixing that. So therefore, everything we do needs to be extremely quick here, because targets or attacks of less than 5 minutes are very common, and typically 5 to 10 minutes. You don't see many attacks longer than that. When it comes to the sizes of the attacks, the size are quite small. A lot of attacks are on private people. There are obviously a lot of attacks on enterprise customers and businesses, but there is a lot of attacks on private people. Here I should mention that since we are such a large player in the internet backbone world, we don't see the smallest attacks. So I can't really comment on those. I would say an ISP or someone else, and probably Doug can talk about that later on, but we don't really see that many small attacks in our network. We don't really look at them because they are typically protected by the ISPs themselves to do that. Attacks are, if you see them spread over a week, you can see that there are more attacks on weekends than there are on weekdays. We can discuss the reasons behind that maybe later on, but this is the way we see them in our network. And as you can see, the timing of the day is also quite different. More attacks in the evening. Most likely that's when people have time to do the attacks. And that's why we see a trend like this. So quite interesting data to see when you need to protect your network a bit more than you need. Well, obviously, you need to protect your network all the time. So this is not a big thing here. One thing when we talk about trends here is that we can see that the trend for carpet bombing is actually larger and larger. This is when you attack more like a full ISP with your attack and not a single IP address. I don't really know the reason behind this. Maybe it is because of companies being very good at protecting themselves, and therefore the attackers are changing patterns. But as you can see in our network, we've seen a lot more of them in the autumn of last year than we've seen previously in our network. So this is a clear trend that we see happening in our network. The size of the attacks and so on are the largest attacks we've seen has been around 900 gig. The way we mitigate them is, of course, that we try to mitigate as much as we can with automation, that the tool we have is kicking in immediately when we see anomalies in the traffic patterns and just throwing away that type of traffic. We obviously still do the manual thing when attacks are very complicated or very large or need some attention from a manual interface. But of course, the trend goes towards more auto mitigation. That's really when you're as effective as you can ever be. So that's kind of the trend we see in the network and so on. So these are just some of the statistics. The time it takes for us to mitigate traffic is going down, which is a good sign, of course. And then final slide really is around Russia and Ukraine. And here I will invite Doug as well to talk about this. We obviously have a large IP network in Europe that goes into both Ukraine and Russia, and thereby we can kind of see what has happened since the war started here, who's attacking who. And as you can see, there is a quite balanced attack pattern here in really ways. I don't think we need to comment much more on this. It's obvious that the sort of cyber warfare is almost equally important as the other type of warfare. But I would say what's more important here in this part of the world is the way the traffic is flying. And I think, Doug, here you have a lot of insights. I've seen you done reports on this before, so maybe I'll invite you to give some comments here around what's going on in this part of the world as well.
At the beginning of the conflict, back in February and March of last year, 2022, we also see a lot of DDoS attacks again against both Ukraine and Russia, so we have. I use a large pool of aggregate net flow to do this. So we aren't one network. We have basically the view into many hundreds of networks through our customers, and can have a composite view to, and DDoS attacks show up very well in this data set. And so we were reporting on this. I got a little bit out of trying to do the play-by-play of the attacks that were going back and forth against Russia and Ukraine, in part because I felt there's a balancing act of, you don't want to reward some punk for launching an attack. So when it's newsworthy, we would comment. Otherwise, there's a lot we're seeing that we're taking to the carriers that can do something about preventing them. In fact, I've had conversations with Arelion staff around that time of making sure that they're aware of DDoS traffic that we could see coming through their network. They're very responsive, and we were able to work together to make sure they had filters in place to scrape that traffic out. I'll say one last thing, and then I'll return it to you. So the other piece of analysis that we've done in the last year is looking at some of the rerouting of traffic by the Russians as they occupied places like Kherson, the city in the south of Ukraine. Starting in June last year, they rerouted all the transit. Instead of connecting back to Kiev and onto mainland Ukraine, it was rerouted through Crimea back to Russia, and this enabled them to either surveil, intercept, block traffic for the people that were residing still in Kherson. When we saw there was an offensive by the Ukrainians in October, November, and most of the region of Kherson, including the city, was returned to Ukrainian hands. About half of the ISPs that operate in that network, in that region, were able to restore their Ukrainian transit. Half are still on Russian transit. So it is the internet is an important part of the conflict.
Yeah, no, absolutely. And I can also say that we've had very much help from you guys and looking at the rankings in your tool. We're actually using that one to track who we are connected to and who the other are, who are connected and who we need to speak to and so on. So your tool here comes very handy for us as well to keep track of this. And I would say we're sometimes, a bit puzzled where the traffic is going. We've signed with customers and then we see the traffic appearing in other places anywhere. So a bit of a weird situation, and hopefully we will it's going to be resolved soon, but who knows. All right, let's jump into the next topic, and here Doug is having much more than I have. I can only say that RPKI is very important for us. I think most of the people that's listening here knows what RPKI is, but it's a way of making sure that you only provide the right type of traffic you're authorized to provide in the internet. And here we were one of the pioneers in the beginning. I could almost believe that we were the first tier one that have this. I checked in the numbers before this meeting, and I could see that on the 20th of January in 2020, we implemented RPKI fully in our network. And that was about 3 months before the next big tier one network did that. So we were very early out here. I would say so far it's been very appreciated by our customers. They very much like that we do this. We actively try to make this better every year by adding more services and helping our customers. But I would say I hand it over now to you, Doug, because you have much more here around RPKI and the development and what you see in your systems, because you know a lot more about what everyone is doing. We only know what we do. So over to you, Doug.
Sure. All right, so let's talk about RPKI ROV, specifically the mechanism that we're talking about. A lot of times we say RPKI, we're really talking about ROV as a particular mechanism that's built on top of this RPKI infrastructure. But ROV stands for Route Origin Validation, and this is our best defense against BGP hijacks due to typos, leaks, all the accidents that happen on a daily basis with the internet. And it is not foolproof. We need additional mechanisms to roll out to completely secure BGP. But this is a huge first step, and we've made a lot of progress that we should take a moment to appreciate how far we've come, because securing global routing is a really difficult task. So, getting into RPKI ROV specifically, how does this work? What needs to happen for this to protect somebody's network and their traffic? So step one is the resource owners, people who own the IP addresses, the IP address ranges, have to create ROAs. That's a route origin authorization, and that asserts within the RPKI system who is the valid origin and prefix length, which is an optional piece of the ROA. You're trying to communicate to the internet what is the ground truth, how is this route supposed to be announced. So that's step one, and then step two is networks around the world have to reject RPKI invalid routes. So BGP routes that arrive at a network that don't conform to the information stored in the ROA. And so both number one and number two have to happen for us to improve routing security. And as you'll see, we've actually made a fair amount of progress. So this graphic is a little faint, but this is from NIST. So NIST is a agency of the U.S. federal government that studies technical standards just broadly, but they have an office that studies routing security specifically, and then they have a website that publishes live stats of where we are with RPKI ROV. And this is one of the graphs off their website showing this positive trend that I'm talking about. So in this graphic, you've got the yellow line going on the top. There's an inflection point a couple of years ago. You can see it's on the decline, and these are routes that don't have ROAs, so they basically can't be protected by the system if the internet doesn't know what the proper origin is, it can't help. Well, that number is declining, and the green is going up is the number of routes with valid ROAs. And as has been commented by some people lately, we are maybe just a few months away from that green line passing the yellow line, and we will have the majority of the routes. This is V4, but V6 looks the same way. The majority of routes in circulation have valid ROAs and are essentially eligible for the protection that RPKI will afford them. Lastly, there is a little red line that hugs the x-axis. It's a little hard to see, and those are persistently invalid routes due to misconfigurations. So this is something that as a new technology, not everybody gets it right. There's a very small amount that are invalid, and that causes some connectivity problems for those folks. But the big message here is the ROA creation is going in the right direction. Having said that, what I thought was interesting last year was I mentioned earlier that I sit on this very large set of net flow data, and I wanted to know, well, we can count routes, that percentage. So it was 43% is where we stand, in the last week. I just updated these slides as far as routes with valid ROAs. But the key insight is that number actually doesn't count how much traffic is actually getting protected by RPKI these days. So not every route is created equal. Some routes don't handle as much traffic as others, And if you were to employ like the data we have, this net flow, and look at how much traffic, using a slice of the internet that we have, how much traffic is going to valid routes versus invalid versus unknown. Nowadays we're up to almost 64%. I think it was maybe 54 when I did this over a year ago at a Nanog talk and a RIPE talk. The majority of routes the vast majority of traffic is going to routes that are valid, and that ought to be a motivating factor for your network to do what Arelion did, is to drop invalids, because that means that by dropping an invalid, that means that you're going to be protecting the traffic that you're egressing. Anyway, so that's I think another motivating factor to drop invalids. And let's take a look at that other side of it. So this is the ROA creation side, but now let's flip on over to the networks dropping routes. So this is a much harder problem to measure. There's been a few different methodologies to try to figure out, how many ASs on the internet are dropping invalids. It's there's a variety of answers that are out there. And so the way I decided to try to approach this was to look at, well, if we just, I'm not going to try to guess what ASs are dropping invalids. I'm just going to say, if I took a valid route or an unknown route, those ought to have the similar profile, because they don't, nothing's limiting their propagation. And compare those to invalids, just to see how many BGP sources, when we look at something like route views or RIPE RIS, how far does an invalid route propagate? It's really different. And I was coming across this in my daily analysis. I thought I'd just go ahead and do this writ large for the whole global routing table. But if you can follow this graphic, what's this showing on the top in the blue, we've got routes, the counts of routes that are not found. The x-axis is how many BGP sources in route views, I think in this case, saw the route. So there's a big peak for things that are globally routed, about 300 of route views sources. It looks very similar for valid, but that should be expected, because both are going to be not filtered. And then when you get down to the green on the bottom, these are routes that are invalid, and they experience a severe penalty of how far they get propagated. And this is a good thing. So those are routes that we want to, in this case, these are persistently invalid routes. So we're just using those for this study. But usually if it's like an origination leak or some other kind of accident, then we want to, the system's working if we're limiting how far they propagate, what's the footprint of that kind of an incident. And anyway, so this is, it's dramatic. It's a big difference. And this ought to be a motivating factor to, if you haven't already, to create ROAs for your address space, so that this system will make sure that most ASs accept the actual origin and reject somebody else's hijack of your address space. And the last thing I would say on this slide is that what's moving the needle on this is really the backbone carriers. And as Mattias said, Arelion was the first backbone carrier to do this, and it's a huge benefit to the internet, and they should be commended for it. Soon after they did this, it seemed there was a trickle effect, and the majority of the other backbone carriers followed in their footsteps and are rejecting invalid routes. Not everybody does, but it's the majority, and that's on a graph like this. A lot of this is how far something propagates has to do with transit, and that is affected by these the backbone carriers like Arelion. What we're going to do now is take a quick tour of Kentik Market Intelligence, otherwise known as KMI. So KMI is based strictly on BGP data. There's no NetFlow or any other data source used in these calculations. And what it does is it takes the global routing table, it goes through every prefix, and scores it, it geolocates it, and then looks at the AS paths to determine how is it transited through the internet. That builds a model of the global internet in both v4 and v6, and then we're able to then allow a user to navigate through and query a number of questions. We'll take a look at some. So for any of the views in KMI, you can separate out between v4 and v6. It's important because the two global routing tables are separate. We can restrict the views by geography. And so what we're doing here is we're just going to limit the analysis presented based on the prefixes that geolocate to the continent, subcontinent, region, country. There's a number of levels of geographic scope that's available. And then there's a few different types of customer base ranks. And we don't have time to get into the details here, but in a nutshell, what's happening is we're trying to separate out those ASs that provide retail service, that originate networks in a market, from those that provide transit to the retail providers, i.e. the wholesale and backbone carriers that may or may not be in the market. So we're on a call today with Arelion, who shows up as number one based on our model of transit. So they are a large network in many regions and countries. On the right-hand side of this insights bar, we can see things that have happened relating to AS 1299 in the last few days. So the this top one here actually is a restoration from a submarine cable cut off the coast of China that affected China Mobile. We saw a day earlier a drop in international transit for China. What we're seeing here is actually the restoration as they rerouted the traffic through another city, and the transit for Arelion popped back up. And so, as you can imagine, this shows up in BGP. And so what we're trying to do is capture that then in an easily readable format for KMI. So with that, you can configure a lot of things: customer gains, losses, provider gains, losses, market entrance, exits for any network, or you can find all of those events for a market. And once you're happy with what it is you're interested in getting news about, you can create a little insights widget, give it a title, what ASs you care about, or you can leave that blank. You can then come up with the geo market you're interested in. These ASs and geo can be used in combination, or just one can be set without the other. And then the rest of these are the same options that were there earlier. Once you've populated that, you can go over to the observation deck and see these. These are some pre-populated insights widgets that we built during a call with folks in Taiwan a couple days ago. And so once you set this up, then you can get a feed of the events that you're seeing based on your configuration in Kentik. Right. So we're looking at Arelion. They do well in the markets, in the rankings for markets. They're all over the world. They they're based in Sweden, so they have do a lot of work, do a lot of business in Europe. In the customers and providers tab, we would list if they had any transit providers, they would show up here. Arelion is one of those transit-free carriers. And then other than that, we see all of the transit customers around the world. Now, if we want to change this to a certain geography, then we would just see their transit customers in India or Singapore. Right now, they are. This is just the global list. And if we were to click on one of these, we could find out who Telmex out of Mexico is. Who are their customers? Who are they buying transit from? A lot of people, and we can set up check out their insights. So there's a lot of things you can do with KMI that's not available anywhere else, and it helps with sales, it helps with marketing, and it helps with the folks in some network architecture roles, such as peering coordinator. If you'd like a demo or like to talk more about it, we're happy to meet up with you and set up a meeting, and we can give you a tour. So that's KMI. Mattias, you guys make use of KMI. Would you tell us a little about how you evaluate?
No, absolutely. No, I can only say good things about the tool. We've been a heavy user of previous tools that's been developed by companies previously to this, but I would say the KMI tool is the best one so far. It really helps us, as you said. It both helps in sales, in marketing, but also from a network point of view. There are quite a times when a customer could call in and complain about, we don't think you're super well connected in this part of the world, and we would love you to be more connected here. Then this tool is really good for us, because obviously we can see in our own tools who we are connected to, but we don't see who we're not connected to. So we can absolutely in your tool see who we're not connected to, and see who has quite a big presence in that market. And there's a lot of things we can draw conclusions from in this tool and learn from, to make sure that our network is better connected in as many places as possible. Then obviously the sales pitch of this is, of course, that we can go into a market. The salesperson can say, okay, I'm going to go to Spain next week. Let's see who the largest providers are in Spain. Let's see who they are connected to. And you can be very well prepared when you come down there to meet customers, because you already know who they're connected to. You know who they are buying from. And for us, finding arguments of why maybe our service could then help them a bit better than the services they're buying. At the end of the day, I understand price is one thing important in our network when people buying transit. But of course, there's a lot of arguments we can build up through your tool. So I would say I use the tool several times a week just to keep myself updated with what's going on in the world, what's happening with our competitors, what's happening with our customers, to see what's going on. Because I think your tool, as you said, almost in real time, you can see who's connected to who and so on. And from that point of view, it really helps us a lot. There's a lot of times we have internal debate in our company about, wow, I can see in this market that we dropped from number 1 to number 2. What happened? We can go through that, what's going on. So, and then obviously, as you've shown, we're globally ranked number 1. So that's always nice to be in a tool where you're feeling you look like your success. Then I fully understand that this is not the 100% truth of everything on the internet, but it's a very, very good indication for us that we're doing something well, and that our internet backbone is well received and well used by our customers. So I would say from our point of view, this is really, really important for us. We have a big focus on being a very high quality internet backbone provider, and this tool is kind of our quality stamp on that we're doing something good. So I can only say good things about the tool. Maybe I can start with the first question. Before, you said that only half of the people are using ROAS. What's stopping everyone else from using ROAS? Is it difficult to implement ROAS, or what's stopping? Why are we not at 100%? Because it feels like it's a given. It should be 100%.
Yeah, I think there's an awareness issue, but you're right. Like of the 2 steps, creating ROAS and then dropping invalids, the creating ROAS is just going into your RIR account and asserting, who should be originating your address space. You don't need to spend any money. You don't have to tinker with any routers. That ought to be, we ought to be 100%. I think it's an issue of just awareness and knowledge. But now the dropping invalids, that not every router can do it. Some people are still using some older models that have got some issues with dropping invalids, doing the evaluations. So I think most people don't use that equipment, but obviously it's out there. That makes it a little harder to do, and in which case it's a great service that backbone carriers like Arelion are dropping invalids, because you're actually then all of your customers, some of those, they're not going to need to drop it if you've already dropped it. So there's a big benefit that you're giving to your customers by doing that. But yeah, everybody should be making ROAS. That ought to be we ought to be at 100% on that one.
Okay, yeah, good. Okay, Andrea, over to you. Have we received any questions?
Yes, we do have a number of questions already. We will try to get to as many as possible. And as a reminder, please submit any questions you have using that Q&A tab to the left of your screen. So continuing on here is a question. The chief scientist of AFNIC recently questioned whether RPKI ROV was worth doing anymore. Do you disagree with this take on RPKI?
All right, we'll stir the pot with the very first question here. Yeah, so this is coming from Jeff Houston, who's a very smart guy. He's been in this business for a long time. He is the author of a lot of parts of internet stuff, including RPKI. He says a lot of, sometimes he has some provocative takes that I think are very valuable because it helps us all try to make sure we understand why we're doing what we're doing. And so his recent take in the past year has been, I'll try to boil it down, but given that a network exchanges a lot more traffic through, like, let's say an access layer network, a residential broadband, something like that, is going to move most of its traffic through its directly to content providers over private peering. And since if you were to count just bits and packets, most stuff is going that way. That's just the efficiency that we've gained in the internet these days. And given that, then RPKI probably isn't going to help a lot for those packets, I guess is his point, and that it's only going to help the transit traffic that you're transiting, which is a minority of your traffic. Again, if you're just counting by bits and everything's equal, I guess that's in my mind where it breaks down. I mean, this kind of fits with his the death of transit idea, where it's all a lot of traffic is going through peering, not much is going through transit. Again, if you're counting by bits, I think we can perhaps all agree, certainly on this call, that transit isn't dead. If it were, Arelion would not exist as a company. Mattias would work somewhere else. So transit is super important. Even if for a access network, it's the minority of traffic, a lot of that is super important. A lot of your DNS queries, a lot of things are going through your transit connection that needs to be secured. And so it is still worth doing, trying to secure internet routing, because even if it were only to help the traffic that you're sending through a transit provider. So I guess I would disagree with that take. I think there's a lot of people who disagree with that take, but I think it is helpful. I think it's very helpful to have a provocative take like that to cause us to go back and look and, like, well, why is this a good idea and why should we be doing it? But at the end, I for those reasons, I disagree.
And I only agree with what Doug said. Transit is
Okay.
important.
Another question here, following up on Mattias's question about RPKI update, other providers have followed Arelion's lead in rejecting invalid RPKI routes. Do you have any insights of why more providers don't do this? I think we'll hand this off to Doug.
Yeah, for the well, there's some cost in rejecting invalid routes. There is some cost to your engineering team. There may be some outdated equipment that needs to be replaced, but there is some work, and I think the folks in backbone carriers are, the technical folks are generally very busy people. There is a lot of work to be done to keep the lights on, keep the traffic flowing. So time is super precious, and it takes a lot to try to justify getting some time away from that to deploy a security mechanism that at some times in the past, and maybe a little bit still today, there's some doubt as to what's the benefit. We're seeing, I think, a lot more benefit these days, and but I think now that Arelion, led the charge here, we've kind of created a tipping point where I think it's now it's more noticeable to have a backbone carrier that's not dropping invalids. There are a couple, and I think people who are in the space know who they are, and I think there's going to be some more social stigma around, why are they not doing this very basic security thing. So I think those networks are working on it, and I think before too long, maybe within a year, we'll have all of the backbone carriers dropping invalids. I think that's not an unreasonable prediction to make.
No, and I can only add there that I actually have seen that in a couple of RFQs where customers are coming to us and ask us to buy service from us that is previously not buying service from us or want to upgrade services. I can see that they actually include this in the questionnaire that we need to respond to become a provider to them. And if we wouldn't do this, we wouldn't be selectable from them. So I would say that's wouldn't happen 2 years ago, but now we actually see some customers and quite the large customers asking for this to be done. So I think this is going to be, I think every tier one that have some large ambitions needs to do this going forward. So I agree with Doug that the ones that haven't done it, they just need to put in the effort. I know it was a big effort from our side. I know the engineers were working day and night to do this, but I think it's paying off right now. So I think we're happy we've done it.
All right, another question. Regarding KMI, what does it mean to say X provider is ranked Y, other than to say provider X ranks at the position according to a proprietary ranking scheme? Does it translate to any other metrics that a customer of those providers might regard as quality? Doug, do you want to handle this one for us?
Yeah, that one's for me. No, it's a good question. Like quality could be, there's latency metrics, packet loss, there's other types of things that one could try to incorporate. This is strictly based on a BGP model, and so it is a scoring based on address space, which maybe sounds kind of limited, but I think over the last, this methodology has been used in this product and a former a product since 2007, and I think even though it's not maybe it doesn't answer the quality question very well, it is useful. It's still useful to try to quickly understand the lay of the land in a market of who's getting service from whom. I think it's a coarse metric, so you've got one AS announcing a /24 is a lot different than another AS that's announcing 200 prefixes. Chances are they're going to be moving a lot more traffic with the more routes, but obviously that's a limited take. One thing that we intend to, we have a long list of things we are looking to add into KMI, and one of those is to be able to pivot between a view in KMI and then to switch over to the views in Kentik Data Explorer, which is basically a mechanism that allows, that's our main way of navigating through NetFlow analytics, and so I think that would be for those customers that are doing both NetFlow analysis with us and using KMI, that would be a really valuable thing to say, all right, we've got these rankings based on this model in KMI, and let's pivot to looking how does this look from the traffic we're moving. How would we rank the same list? Because it's probably going to be a different ranking based on the traffic that's going through their network. So we do have plans to try to add some other dimensions using other data, but right now it's just strictly a BGP tool.
And I can just add there that we obviously understand this has nothing to do with quality. But in some way, the way we think about this is that if we would have low quality, we would start to lose customers, and thereby we would lose in the rankings here. So in some way, it is connected to that one. You can't really be in the top 10 of the world if you have low quality. That's not going to work like that. You will fall through the rankings here. So the tool is not measuring quality at all, but in some way it does, because you can't fool the rankings in some way. So that's the way we see it.
And we have other synthetics products that are meant to do measurements around quality of traffic. So like either performance latency measurement, packet loss. Like we actually have another a line of products that answer those questions. And so that's where I would point somebody to go to if they wanted to get more of a quality type answer.
All right, another question for Doug here. How can Kentik identify the type of the IP traffic, for example, wholesale, retail, or corporate?
Yeah, so we have a somewhat simplistic methodology here where we're looking at the AS path, and if it's we're looking at in this model, if it's retail, it's an AS that's originating address space in a market. If it is a transit provider that's singly homed, then they get transit score, retail score as well. The next AS up in the AS path that we've classified as transit is going to be wholesale. So that's going to be receive the score of that address space for their wholesale score and ranking. And then the next layer up is backbone. So obviously we can, I can come up with ways that this breaks down if we have, you know, a situation where there's an AS that is like several layers deep, then you can have these cases that, you know, someone's maybe not really providing backbone, but we're getting a backbone credit because we're more than a few hops away. But I guess the issue is that you'll find that on those longer AS paths, there isn't the same splay there's actually a fair amount of single homing going on that enables those long AS paths. It's rare that you're going to have like a long list of ASs that all have diverse transit. It starts to, you know, peter out pretty quickly. So again, it's a model, and I think it's served us well for a while. And I guess the other thing that I'd say is that if you are using the product or you're taking a tour, feel free to shoot me an email, or you know, you can write an email to us. I'll be the one who answers it. I've been doing this for a long time, and man, I love talking about this stuff. So we usually discover something that's interesting that we didn't know before. But yeah, that's in a nutshell how that works.
All right, we have a question from an audience member in Denmark. Could you indicate how similar or different KMI is to previous industry standard tools like DYN and Oracle Cloud Infrastructure IP Transit Intelligent? For example, when looking up the total Arelion IP transit volume in the Nordic countries, would you get similar results in KMI compared to DYN?
Yeah, so it's dying. So that just a quick comment on my bio. So I came from a company called Renesas, who had created maybe the first version of this style of product, and it was my first job, starting back in 2009, was to take care of this. I would be writing, working with folks from Telia at that time, answering their questions, and so that's where we kind of came up with a lot of the methodology that is it's similar to what we're using now. So as far as Renesas was bought by Dyn, and Dyn was bought by Oracle, and that tool continued on until Oracle killed all of the Renesas tools in 2020 and killed the whole office. And I worked there until everything was killed, and then I moved over to Kentik, and basically we had customers that we had been working with for over a decade come to Kentik, knowing that myself and a couple other of the Renesas alumni had moved over to Kentik, and said, like, hey, we could really use this. This was an important product for us. Would you want to try to build something that replicated it and maybe even make it better than what it was before? So there's a lot of echoes of the similarity with the former instantiations of this product, because it's the same guys who made the previous versions that are making it for Kentik. So I think if you have any familiarity with, it's gone by a few different tool names over the years. There was IP Transit Intelligence, Internet Intelligence. Transit, I forget all the names. It's been rebranded a few times, but under the hood, it's quite similar. And yeah, try it out and let me know what you think. And I'd be happy to get on a call with this individual. We can walk through it, but it ought to be like a super updated version of what that old thing used to be. Because to be very honest, that tool stopped getting worked on in 2010. And it continued on for another decade. Kentik doesn't operate like that, to leave a product lingering for so long. And so we are presently working on rolling out features and functionality in that product, and we see a big vision of the future of what we can do with it. And so that's something that nobody's been doing that for a while at this point.
All right, we have a question from someone who operates a regional research and education network in California. They don't intend to expand their customer base beyond that space, but they are looking for new networks to peer with. Is there a use case for KMI for regional networks, specifically for peering research?
Let's see. So, yeah, there is. Well, there's a use case. So we often have peering coordinators use this tool. That's a common use case for both a large carrier like Arelion, but also content providers need to know, need to pull up a country at a glance, figure out, who are the main carriers, who are they getting service from, have they covered, is their peering strategy covering all of the networks that are the main players of any country of the world. So that's the peering strategy for a research network. I guess if it's for peering research, you'd have to reach out, and I think we'd have to discuss. I do a lot of research myself, and so maybe we've got some similar interests, and maybe there's something we can collaborate on. As far as improving the peering of the California Research Network, KMI could be helpful there too. But I guess I would encourage this person to try to reach out to me directly, and maybe there's something we can work on together.
All right, another question. How is RPKI improving specifically even in this past or current year? What is new that you could talk about from a carrier perspective?
Let's see. So I'll take this one too. Let's see. I guess let's say I'll start. I'll answer it in a couple different ways. So there's the first thing is there are actually a lot of incidents that are taking place, and I think maybe it's on somebody like me who's in a position to communicate about this of routing snafus that are getting uh, yeah, that are getting uh, limited. The impact is limited due to RPKI. So there was an incident just a couple of weeks ago. There was a leak out of PTCL out of Pakistan, was basically announcing they must use this internally on their network. They were globally announcing some Orange France Telecom address space that Orange has a ROA for that, and so its international carriers, PTCL's international carriers, were blocking the route. They had one international carrier that didn't drop invalids. I picked up on this. We have a good relationship with Orange. They were able to reach out to PTCL. They killed the route, but that the propagation of that. I'm sure. I think in this case it was a mistake. A lot of these are mistakes. That didn't propagate very far because of RPKI, and that potentially could have disrupted some of the customers of Orange. And there's things like that that are happening on a regular basis, and I see them in our data. A lot of this is just accidental stuff that is not causing problems, where in the past it would cause problems. So I would say that maybe it's not as fun of a story to tell, but we have to kind of come up with a way to communicate what is that speaks to the benefit. As far as like what's new, I think the folks who spend a lot of time thinking about routing security are looking at RPKI ROV as this is a great first step, a lot of success here, and now how do we take the additional steps to completely secure BGP? And what's needed now are things around BGP sec, so that would cryptographically ensure that the AS that's originating something is the one that it is. Right now, you could forge a AS path and defeat RPKI. This is why we say it's more for accidental typos and leaks versus a determined adversary. And then there's ASPA, which is another mechanism that is currently being rolled out, where a provider would assert what are its transit relationships, and that would enable others to spot a leak that is the leak is occurring in the middle of the AS path as opposed to the origin. So I think there's a lot of enthusiasm, I think, in our space to say like, hey, we've actually made some progress here, and we haven't completely solved this very, very gnarly problem, but it seems like there's a clear path on how, and maybe into the next 10 years it takes us to completely roll all this out. But I think there's a growing consensus around what are the next steps in order to try to handle that issue around the determined adversary. And if we could get that, that would really, completely secure BGP globally and internet routing. So I think that's where we stand right now.
Mattias, do you have anything to add there?
No, I know. I can just agree. There are things we see in our network almost on a daily basis where we see that we're saved by this, and there's things we can pick up on a lot earlier. So I completely agree with Doug. We wouldn't have handled these before. It would have been manual, and we would have spent hours trying to figure out why the traffic is flying like it is. So I think it's been really important for us, and we've actually been saved by this a few times.
All right, we briefly have time for one more question. So this last question, if CADA's AS ranking and BGP HENet are free, why would a company purchase KMI?
Yeah, good question. I get this every time I start a conversation with somebody about KMI. And so I, too, am a user of bgp.he.net. So this Hurricane's free public tool for looking things up. And it's super cool, it's super useful. A lot of people use it. And then obviously there's also CADA. There's a few other outfits that do telegeography, publishes some rankings. I think if you were to do a bake-off between these tools, there is an enormous amount of functionality that you're getting out of KMI that you're not going to get out of the free tools. The little tour we did a minute ago kind of just touched on it, but just the ability to identify things that you care about and be notified of some specific events of customer gains, losses, transit gains, losses, be able to change the view and restrict it to a particular geography and see what that, how does that look? Usually in all these tools, there's no sense of geography. There's no way to drill into a particular area of the world. That's really useful, but that's just one of a number of things that that's in KMI. So I get this question a lot, and I think it's a reasonable question. If I were on the other end of this conversation, I would ask the same thing of like, why would I there's a bunch of free tools out there. Why don't I just use the free tools? And they're like, well, I guess it depends how much your time is worth to you, because what this is for the folks in sales and marketing that use this, they just need answers. They don't want to be writing code to or using some tools that are a little bit more esoteric and require some more domain knowledge to interpret. They need to have the answers served up. They can get on with the main work of making their sales. So again, I think that if that person wanted to reach out, I love talking about this stuff, so we can get on a call and I can show them what you would get and what you're getting for your money.
All right, well, that was our final question. We had a lot of great questions today and we couldn't get to them all, but we will try our best to get back to everyone who submitted personally after the webinar. Thank you for attending this Fierce Telecom webinar and for submitting all your great questions. I'd like to thank our speakers for participating and Kentik Technologies for presenting today's webinar. A recorded version of this webinar will be available for you to access within 24 hours using the same audience link that was sent to you earlier. Thank you again for joining, and we look forward to seeing you at future events.